En estas sesiones de la Cátedra Gaos. Esta es nuestra cuarta sesión a cargo del profesor Franz Berto, que nos ha prometido que en el transcurso de las próximas 3 sesiones nos va a hablar finalmente de su propuesta más personal, así que estaremos muy atentos. Muchas gracias, Franz.
Gracias. Okay, so today is going to be heavy duty formal epistemology / epistemology. Okay, so apologies in advance if somebody doesn't have a taste for formalism. But Aurelia's instructions were on Wednesdays, try to make yourself understood by a broader philosophical audience. On Thursdays, you can play with your logical toys and so on. So that's what I'm going to do. Okay, so so try to sell you this hyperintentional account of propositional contents. Okay, well, propositions are 2 components. I have 2 components. I told you that Diablo calls them directed propositions, propositions which are directed to words. Okay, they are topic or subject matter. Okay. But what is it that can be directed towards something? Remember that Diablo says that aboutness is the relation that meaningful items have with whatever it is that they are on or off or about and so on. Well, mental states can be directed towards things. Situations, states of affairs are there in the world. Okay, that's what we usually call intentionality with a T. And the key idea here is that, well, we're going to talk about ascriptions of mental states, attitude ascriptions. So somebody knows that P, or believes that P, or believes that P conditional on Q, or supposes that blah, blah, blah. All of these get propositions as clauses, right? That's why they're called propositional attitudes. And the idea that I had when I started to explore subject matter semantics was, well, maybe what makes for the intentionality of a propositional mental state is that it has to be directed towards whatever the proposition, which is the content of the state, is directed to. Okay? And so once we have propositions which are directed towards subject matters, well, the corresponding mental states better be directed to those subject matters. So if you believe that P, and P is one of my thick propositions, which have a certain subject matters, well, your belief is about that subject matter. That's what you're thinking about. Okay? And we think about this and that all the time. When I think that John is happy, my thought has a subject matter. It's about how John is doing. When I wonder whether the markets will fall, I'm wondering about a certain subject matter, whether the markets will fall. When I believe that John is tall and handsome, also my belief is directed towards the subject matter. And my belief is about the height and looks of John. So if we buy that idea, we can start doing epistemic logic and in general formal epistemology by having attitude descriptions whose propositional contents are thick or directed hyperintentional propositions, propositions which point towards subject matters. Here's how this approach is going to be different, as I will unfold it to you today, from standard Hintickan epistemic logic. And you may be familiar with Hintickan epistemic logic, which is based on a simple idea. It's the mainstream approach in epistemic logic. It's the idea that Hinticka had, which is very simple. He basically said, well, let's take knowledge or belief as if they were ordinary, normal modal operators. So in the Hintickan approach, one axes that phi, but X can be knowledge or belief. It can also be some other attitude descriptions, but the 2 which have been more explored than any other one are knowledge and belief. So it's systemic logic. So that ascription of knowledge or belief is true at a certain possible world, W, just in case phi is true at a bunch of worlds accessible from W. Okay, so it's just a normal model operator. Okay, and the accessibility relation between worlds, which we know and love since Kripke, that gets an epistemic reading. Okay, so the epistemically accessible worlds are the worlds which are, I don't know, compatible with your evidence or consistent with your beliefs, or worlds where things are as they would be if your beliefs were true, or there are worlds which are ways things could be for all you know, and so on. But otherwise, it's just the usual box of normal model logic. Now, the approach that I'm going to propose to you is going to differ from the Hyperintension standard approach in three main ways, and the really innovative one is the third one. But the first one in which it differs from the standard Hyperintension approach is that the Hyperintension basic operators are one-place operators, where the operators that I'm going to tell you about today are two-place operators. They're binary. I'm using this locution since topic sensitive intentional with the T modals. Okay. They are modals because, as you will see, they are modal operators. There are various kinds of quantifications over possible worlds. Okay. They are intentional with the T because they represent intentional states like knowledge, belief, supposition, imagination, and so on. And they are, guess what, topic sensitive. You'll see that there is a certain constraint that is related to topicality of subject matter embedded in the semantics of these operators. Okay, so I will only talk about binary ones in the topics of thought book, chapter 7. I have one place since they are to represent plain belief. So somebody believes that, fine. But I will only speak about the two-place operators, which are explored at a greater length in the book. They take 3 full chapters of the book. So the general form they have is this one, x phi psi. The generic reading is something like, given phi, when x is the psi. We get more specific readings soon, okay? Where xing is the ascription of a certain mental state or aptitude. The second difference is that my two-place TSIMs are variably strict. They are non-monotonic. I'll show you what that means in a few slides. And let's see that the non-monotonicity at issue is to represent the contextual selection of information that one imports into the content, which is known or believed or conditionally believed or supposed and so on the basis of input phi. Again, you get more precise readings when I get to the specific operators. So they work a little bit like a kind of non-monotonic conditional. That's why the generic reading, given phi when x is that psi, should give you some intuitive hint. So in this sense, epistemic logic in sim clothing becomes a kind of conditional logic. The third difference, which is the most important one, is that we will see all of these operators encompass a topicality or aboutness filter. So they are sensitive to the subject matter of the things which are supposed, believed, conditionally believed, known or knowable, and so on. So they stand for intentional states which are directed to words that are about a certain content or topic represented in the mind. So I really invite you to endorse, at least provisionally, a conception of attitude descriptions, whereby when we ascribe an attitude, we really take seriously the idea of intentionality with a T. Okay? So when I say Mary believes that P, I'm not just saying that Mary has a certain sentence or a sentence-like representation token in the head. I'm saying that she has a certain intentional state, which is directed towards something. Okay, that's what the mental state is all about. Now, the first and the second feature have been around. There are two-place operators expressing, for instance, conditional beliefs. I will also give you a treatment of conditional beliefs today, or belief revision, for instance, in so-called DEL, dynamic epistemic logic. That's a thing on which I've been working a lot. There's a whole industry of dynamic epistemic logic in Amsterdam at the ILC. And also in modal recaptures of AGM. You may have heard about AGM, the theory by Alcuron, Gardner, Fox, and Mackinson. It's an axiomatic theory, which is a mainstream approach to formal representations of belief revision. It's a theory that formalizes how idealized agents should revise their beliefs in the light of new information. Okay. The third bit is the really new one, as I said, even though you can find some forerunners of my approach. For instance, he works on analytic entailment, pari logics, for instance, and also works by old work by Fine, from Ferguson, and also in an approach to epistemic logic, which is called awareness logic, of which I will not talk too much today. Okay. Next, I'm going to recap a few things I already told you about in the previous talks. What's aboutness? I just keep quoting Yablo. That's the relation that meaningful items bear to whatever it is that they are on or off for the address of concern. That's what I've been calling the topic of subject matter. And I told you that that comes with a mereological view of content, what a sentence is about can be included or properly included in what another one is about. Content should study mereological relations. They should be capable of being fused into wholes which inherit the proper features from the parts. And that's the view that I'm trying to sell to you now. Belief, knowledge, cognitive information, mental simulation as representation of mental states, their intentionality with a T. They're about states of affairs, issues, situations which make for their contents. These are the things that are called topics, and I've already provided a simple mereology for them yesterday and the week before. Because they are sensitive to subject matter, the operators will be hyperintentional. They will make distinctions between necessarily or logically equivalent contents. And the spirit, again, is that our mental states, believing, supposing, desiring, hoping, feeling, can take logically or necessarily equivalent contents different. What I'm going to do is this. In section 2 of the talk, I will give you a basic semantics for a generic thing. In section 3, then I will add constraints on the accessibility relations that I will have used to give you the semantics for the operator. On functions, we will see that we can formulate the constraints using relations and functions equivalently. And those constraints will validate different logical consequences of different logical principles. And at the same time, they will suggest different interpretations for them. Okay. So if you have one constraint, you get a certain reading of the operator in which it represents knowability, your information. It's an epistemic operator. If you have a different kind of constraint, it will represent supposition. If you have another bunch of constraints, it's going to represent conditional beliefs and so on. So the situation is kind of similar to what you get in normal model logics, if you're familiar with that. So that's the basic normal model logic, the case system. That's the weakest one. It has no constraints on the accessibility relation, right? And then on the semantic side, you can add a constraint. Okay, like, well, suppose their accessibility is reflexive. Okay? That's going to validate the logical principle, right? That's going to make your operator factive, right? And when you add that constraint, you get some natural readings for the operator, and other readings are not so natural, right? So if you have that constraint, you don't want the model to represent belief, because beliefs can be false. Okay? But you want to add that constraint if you want the model to represent knowledge, because knowledge is factive, right? So you want difference from guy knows that phi to hold, because you can only know true things, okay? And to do that, you need to add reflexivity in the accessibility relation. Other constraints can be more controversial, like S4, S5 constraints. For instance, if you want the box to represent metaphysical modality, then many people think that S5 is the way to go. Okay. For other kinds of models, maybe you want the weaker S4, and so on. Anyway, that's how it works, right? That's just normal model logic. Basic normal model logic, no constraints on accessibility. You add constraints on the accessibility in the semantics. They validate certain logical principles, and they also suggest certain readings for your box, for the normal box. Okay. It's going to be similar here. There are 3 constraints or sets of constraints. I don't think I'm going to be able to go through all of them. Maybe I will do the first and the third one. The first one that I'm going to explore is a constraint that allows you to relabel our generic SIM as an epistemic operator, an operator that represents a certain kind of knowability. In particular, that's knowability relative to information. So we'll see here the reading is something like, given information phi, total information phi, one would be positioned to know that psi, which is inspired by a classic and very intuitive idea from Gretzky that I will get back. The second one is another kind of constraint. You get a suppositional operator, an operator that expresses mental simulation or suppositional thinking. It expresses the idea that supposing that phi, one imagines that psi. Maybe this is the one I'm going to skip if I don't have sufficient time, because I care a lot about the third one, which is conditional belief. Okay. If you add another bunch of constraints, that same tissue becomes a conditional belief or a belief revision operator. Given phi, one believes psi, or conditional on phi, one believes psi. So that's not plain belief. That's not just believing that something is the case. It's just believing something conditional on something else. Sometimes I add static because, again, I'm an adopted dynamic epistemic logician, and dynamic belief revision works differently from what I'm going to talk about here. But I will not tell you about dynamic epistemic logic, so that's going to be redundant for our purposes. Okay. And here I will show you how this operator can reduce a certain kind of medium welcome idealization of cognitive agents that one gets both in standard doxastic logic, Alahintica, and in the standard AGM approach to belief revision. Yeah, that's the plan. And then in section 4, I will finish mentioning some work in progress, but there's a number of people who are working on this stuff. They come up with expansions, completeness proofs, and so on. Yeah, okay. So first, the basic semantics. Start with language, simple propositional language, which has set of atoms, PQR, subscripts, negation, conjunction, disjunction, a state conditional. The X stands for our generic sim, auxiliary symbols, and I'm going to use Greek letters as meta variables for formulas of the language. The well-formed formulas are the atoms and usual rules. Okay, this is the only new bit. So negation, conjunction, disjunction, state conditional. So phi strict implies psi, and this is the new bit. Sim. We identify the language with the set of the well-formed formulas. And in the meta language, I'm going to use this notation, W and subscripts. These are ranging of the possible worlds, X, Y, Z, and subscripts. They range of the topics of subject matters, and a little bit of meta-linguistic notation, the usual way, conditional, conditional, and so on. Just to abbreviate the meta language. Semantics. A frame for a language is made of 6 items. The first one, the big W, is the usual familiar set of possible words. Nothing new. The second item is a set of accessibility relations. So we don't have a single accessibility relation, we have a set of them. So each formula of the language has its own accessibility. Okay? So you got a whole bunch of accessibility relations indexed by formulas. And they're all binary accessibility relations. Right? These are the ones that can satisfy different conditions and give the different readings of the TSIMs accordingly. Okay. So the semantics is syntax sensitive. It's applied to formulas. If we have certain constraints, that drops out as idle because it becomes proposition sensitive, or at least sensitive to sets of words rather than formulas. I'll get back to this later. The third item, big T, is a set of topics, what the formulas of the language involved in intentional descriptions are about. So again, I give you that very abstract and neutral characterization of topic. There's just a bunch of things. And yeah, we stay silent on what topics are, metaphysically speaking. We only ask them to obey the constraints that are coming next. And they're the same as the constraints that I mentioned yesterday and the week before. And they come with the fourth item in the frames, topic fusion. You're familiar with that. That's just the usual operation, which is an important commutative associative. Takes two subject matters, lumps them together. Again, for simplicity, it's always going to be defined on the set of topics. So whenever you got these topics, you got a fusion. You can define again, that's not news, I didn't mention that yesterday in the week. You can define what it means that a topic is part of another. Out of fusion, the usual way X is part of Y, when the fusion of X is Y. It's just Y, and it's a partial order. And so the set of topics with the fusion operation, and it is just a usual join similarity, usual in the sense that it's the same as yesterday. Now, that it's complete, take any subset of the set of topics, there's going to be a fusion of them. Again, this is all just to make the semantic things simple. The fifth item is a function which assigns topics to atomic formulas, what the atomic formulas are about, their subject matter. That's extended to the whole language in a simple way. Take any formula phi of the language. This is the set of atoms, the set of atomic formulas that show up in that formula. The topic of the formula is just a fusion over the topics of the atoms. Okay, that says a formula is about whatever the atoms that show up in it are about. That's just to ensure the my beloved topic transparency for the connectors. Okay. Yeah, we already know this. You know that we don't get as fine-grained that the syntax of the language. So the topic of phi is the same as the topic of the double negation. The topic of phi is the same as the topic of not phi, topic transparency. Topic of conjunction and disjunction is the same. It's just the fusion of the topics of the conjuncts of disjuncts and so on. Model is a frame plus an interpretation. An interpretation relates words to atoms. So that notation is atomic formula P is true at that possible world. This means it's not true at that possible world. And the semantic is standardly bivalent. Okay? So any atomic formula is either true or false at any good or possible world. Not both, not neither. Okay. So no many valued semantics here. No true contradictions. Even though there's going to be some kind of paraconsistent friendly setting that will pop up in a few slides. Okay. But still, in this respect, the semantics is very classical. Next, that's extended to all formulas of the language via the following two conditions. The only new bit is the last one. So negation works as usual, right? Not phi is true at the world, if and only phi is not true there. A conjunction is true at the world, if and only both conjuncts are. Disjunction is true at the world, if and only one of the two disjuncts is. This is just a preconditional. So phi is true implies psi. That's true at the world, if and only all the phi worlds are psi world. Yes, any world where phi is true is also world where psi is true. There's a new bit. Okay. These are the two conditions for that SIM operator. Conditional on phi when x is that psi. That's true at the world, if and only if. And that's a two component semantics. So for given phi when x is that psi to come out true at the possible world w, we ask for two things to happen. One, this bit here, two, this bit here. And the first bit says, well, psi must be true at all worlds W1 one looks at by the accessibility determined by phi, the accessibility to index it with phi. That you may call the truth conditional or strictly truth conditional component, making of the operator a variable strict for the phi over world. So the first condition is take any world W1, which is accessible from W, given phi. Okay. Well, psi is still there. Okay, that's the first bit. The second bit says, well, psi must be fully on topic with respect to phi. Okay, so the topic of psi is included in the topic of phi. Okay. So what psi is about is fully within what phi is about. That's the boundless preservation component. Okay. You can formulate the truth conditions for those operators equivalently using set selection functions. Now, if you know your Lewis, if you write counterfactuals, so you're familiar with the standard account of counterfactuals, you see that that's a kind of like a counterfactual condition now. Remember what Lewis says, yeah? The conditional is true at the world, just in case the consequent is true at a selected set of words that make the antecedent known. And for Lewis, those were also the most similar words on the antecedents, right? There's no similarity requirement here yet, but there's going to be an ordering of words that will pop up later, but it's not there yet. And you may know that Lewis formulates the semantics for the counterfactual using the relation and also using the function equivalently. So here's the function formulation. Each formula of the language now comes with a function that takes as input the possible word and spits out the set of accessible words. Okay. So f sub phi takes as input the possible word, spits out, guess what? The set of words which are accessible by the corresponding accessibility relation. So if you take this as the truth set of phi, the set of words where phi is true, you can rephrase equivalently part one of the twofold truth conditions that I gave you. Just say all the phi selected worlds make true psi. Okay. It's exactly the same thing. The two formulations are equivalent. It's just that sometimes it's easier to make a pointer to express a constraint on the semantics using the relation. Sometimes it's easier to use the function. Good. And then finally, so I've given you the formal language, I've given you the frames, I've given you the recursive truth conditions for all the formulas of the language. And now finally, we get the notions of logical truth and logical consequence. And these are completely standard model stuff. Logical consequences, truth preservation at all worlds of all models. Okay. This set of formula, so that set of formulas entails psi, if and only if in all models, And for all worlds of those models, if all the formulas in sigma are true, then also size. Totally standard. As a special case, logical validity is just determined by the empty set of premises. So it's just truth at all worlds of all models. Okay? That's just really standard normal model logical consequence and logical truth. Nothing new there. That's a pretty conservative setting. I said, here are non-classical logicians in here. That's just model logic with a bit of topicality added to that, right? And I told you that I went for this setting because I wanted to fight one battle at a time. I wanted to convince people that subject matters can do a lot of work in formal epistemology and epistemic logic. So I tried to keep all the rest as classical as possible. But sometimes there will be troubles with this setting, and I will try to always point at the fact that the troubles come from the fact that the setting is too classical and too conservative. You know, I'm a non-classical logician, so here I really try to restrain myself. I don't want to get too exotic. Okay. Good. That was the basic semantics. It already validates a number of things. You can get stronger logics by adding semantic constraints. So not all of these are very important. Some of them are. So this one, C0, says all the phi worlds are selected. Okay? So all the worlds where phi is true are worlds which are selected by the corresponding selection function. C1 is the other way around. It's the converse. It says all the phi selected worlds are worlds where phi is true. Right? So it's the converse. Right? Yeah. C2 not very important. C3 is important. It's a bit of mouthful, but it's a condition that you always find or often find discussed in literature on conditional logics. Sometimes it's called uniformity. I will give it another name, which is, yeah, it's instrumental to what I want to talk about. So C3 says, if all the phi selected worlds make group psi, all the worlds selected by the sub-phi selection function are worlds where psi is there. And vice versa, if all the psi selected worlds make group phi, right, then it's the same bunch of worlds. Okay? Right? C4 is also not very important. I just put them there because if you add a certain kind of thing to the semantics, all of these C1, C2, C3, and C4 become automatically valid. Anyway, the three interpretations that I have in the slides come respectively from first adding C0. That's the first one I'm going to discuss. If you add that one, you can get a reading of the TSIM in which it makes for a certain knowability operator. The second one is the one that I'm probably likely to skip, in which you add C1, maybe C3, but I'm going to skip that, I think, because I will not have sufficient time. I will speak about the third one, the one for conditional belief. You get by imposing a total ordering on the set of worlds, kind of like heuristic similarity ordering, but a bit different in a sense. You can do that. If you impose a total ordering of world, any total ordering, one can prove that all of these C1, C2, C3, and C4 become automatically valid. You don't need to add them manually. You just totally order the worlds, and all of these turn out to be validated. Okay, good. In each case, we only look at models that satisfy the relevant constraints. Of course, I can't keep you here for hours and hours, so I will only speak about some validities and some invalidities that you get and which are worth discussing. There's many more in the book. Okay, okay, so first one. C0 says, remember that all the worlds where phi is true are selected by the set selection function. Okay? But allows the other way around for selected words which are not phi world. It can also select words where phi is not true. When we get that, I relabel the operator with a K, and I say that it expresses the idea of knowability of psi relative to information phi, KLI, knowability relative to information. It represents an agent who's positioned to know certain things, psi, because the agent has certain relevant information phi. Nothing. This is not knowability relative to evidence. It's not what you can know given your evidence, it's what you can know given your information. Maybe it's just a terminological point, but we went for this terminology because, you know, there's a huge debate on whether evidence is facting, right? And right now, the winning side is the Williamsonian side. So, because for him, evidence is knowledge. You know, the famous E equals K Williamsonian motto. Okay, because knowledge is factive. So if you have evidence that P for Williamson, P is true. Okay, we didn't want to compromise our framework with talk about evidence in this debate. So we only speak about what is knowable for an agent given certain information. Now, there's also people who think that information is factive, like Luciano Floridi. So Luciano thinks that even if you have the information that P, then P must be true. But that's way more controversial. Okay. And the account of information that we endorse is such that it's not factive. You can have false information. Okay. Good. And the idea goes back to Brazzi, and it's kind of obvious because it says, well, knowledge depends on the available information or empirical information, because the role of information on one goal is to narrow down the set of epistemically viable alternatives. Okay? So in this reading of the accessibility, you say, relative to W, W1 is compatible with knowledge based on the total information. That's fine. Now, when you get this, here's the first validity. I just call it factivity. We call it factivity. The proof is trivial. It captures the factivity of knowledge in the following sense. It says, when you're positioned to know psi based on the information that phi, and moreover your information is true, then psi is true as well. Okay. But phi needn't be true, because we don't endorse an account of information whereby all information is true. Dretske takes information to be factive. Okay, we don't. And so KRI is neutral on that. And in fact, this is not valid. The fact that phi positions you to know that psi, it doesn't imply that phi is. Next is another sample validity. KRI and actually all the SIMs is closed with respect to conjunction elimination. So when a certain amount of information phi positions you to know that psi and chi, it also positions you to know that psi. It also positions you to know that chi. So you know the conjunctions in particular. You say, no? Yeah, of course. Right? But of course, it's not so obvious because the tracking notion of knowledge doesn't work in that way. And that's been taken as a problem by lots of people, including Kripke, who makes heavy weather on Nordic for this. Okay. Why? Well, because here's the broader landscape. KRI allows knowledge not to be closed under logical consequence. So, you know, there's that famous debate on epistemic closure. Should knowledge be closed, fully closed under logical consequence? Huh? Some people say yes, like Williamson, Hawthorne, and other people. Some people say no, like Nozick, Dretske, and a number of other people. Okay, we are on the no side. Knowledge is not closed. At least this knowability of it is not fully closed under logical consequence. Whoever rejects epistemic closure should say something on which particular instances of closure are supposed to hold, because otherwise you have what Kripke calls egregious violations. Okay, cases in which knowledge should be closed and it's not. And Kripke criticizes very heavily Nozick because in the Nozick famous tracking account of knowledge, sometimes you can know a conjunction, but you don't know the conjunctions individually. And Kripke says that that's unacceptable. Okay, so this validity I mentioned just to show that KRI is free from this kind of trouble. Next, all SIMs share two core features. They are non-monotonic and they invalidate closure under strict implication. So these are two invalidities. Monotonicity fails in the following sense. You can be positioned to know that psi, given information phi. Sometimes when you get more information, phi and chi, you're not positioned to know that psi anymore. Okay? So knowledge is defeasible in this sense. Okay? Sometimes you can be positioned to know something based on certain information, and give you more information, you're not positioned to know that anymore. And that's possibly the most important one. Closure under strict entailment fails. So sometimes, given information phi, you're positioned to know that psi, and psi strictly implies chi. Now that means there's no way that psi is true and chi is false, right? Because that's a strict condition. Any possible word where psi is true is one where chi is true. Still, it doesn't follow that based on the same information phi, you're positioned to know that kind. Like, given certain empirical information, you can know that you have hands. If you have hands, then of course you're not a brain in a vat. But given the same empirical information, you're not positioned to know that you're not a brain in a vat. Okay. Right. A comes from variable strictness, so that's kind of standard. B is the crucial thing, and it comes from the fact that information is topic sensitive. So if I didn't have the topicality filter, that would be valid. It's invalidated crucially by the subject matter or topic constraint. Although the idea is that information is topic sensitive here. Although all the psi worlds are chi worlds, that's all the phi selected psi worlds are chi worlds, phi may be information about the topic of psi, yet not information about the topic of chi. In the paper, in a paper that I wrote with Peter, and also in a chapter of the Topics of Thought book, we argue that you need both A and B to deal with the famous Kripke-Harman dogmatism paradox, a famous paradox due to Kripke that was first published by Jules Harman, whereby knowing agents seem to be immune to rational persuasion and new evidence. I'm not going to get there because it's a story which is too long. And of course, I already anticipated that. Failure of closure, B has with Cartesian skepticism, right? You can know your position to know given your sensory perception and information that comes to that, with that you have hands. Having hands is incompatible with being a bodiless hand in a bodiless brain in a vat, but that empirical information doesn't rule out a radical sensory deception. And so it does not position you to know that you're not a brain in a vat. Okay. Lots of time. I will skip this stuff on the stability of knowledge that we still have, and then I will skip the second reading because I want to tell you about the third one. Conditional belief. There you go. So, here's another way to get a thing, a specific thing. Impose a total ordering on the set of words in a sentence. If you do that, I already said that you automatically get all the conditions that I mentioned earlier. Then you get a system of spheres in the side of Lewis, in the style of Lewis. So maybe you're familiar with that. Again, if you know you Lewis, you know that at some point in the book, Lewis has all of those pictures of the set of words, right? You got the system of nested spheres, okay? And the smaller the sphere inhabited by a world, the closer it is, okay, to the base world. That's a centered system of spheres. So the base world is in the center, okay? Here you have a similar thing. The words are totally ordered by an ordering relation, but it's not centered. Here's how it works technically. You add a function to the semantics, I represented with the dollar. It assigns to each possible word a finite set of nested subsets of the set of possible words. Okay, so S0, S1, and S1, it's finite set, indexed by some native number, and they're nested. So S0 is the smallest, S1 is a bit bigger, S2 is a bit bigger, and so on, up to the biggest one, which is just the total set of words. Okay. Next, for each formula of the language phi, and for each possible word, this is how the selection function works now. If phi is impossible, to have no possible word, then the set selection function splits out the empty set. Otherwise, if phi is possible, okay, it splits out the following. The smallest sphere whose intersection with the truth set of phi is not empty. Okay. Okay, I use this setting in the book to target the standard AGM account of belief revision. In this setting, we will label our operator as a conditional belief. So now it reads conditional on phi one believes that psi. Or after revising your beliefs by phi, you believe that psi. And now the accessibility makes us look at the most plausible worlds where phi is true. Because that's our conditional belief and belief relative revision. I have a certain system of beliefs, okay? In the light of this system of beliefs, some words are more plausible, closer to my beliefs. Some words are more remote, more implausible, given my beliefs. When I revise by phi, so phi comes in, okay, I make the minimal adjustment to preserve consistency with the new information. Okay. So I look at the most plausible words or phi is 2. Yeah, that's what I just said. That's a traditional reformulation of the Lewis semantics, sphere semantics need to grow back to the 80s. But because it's believed, we don't demand even weak centering. So we don't demand that the base world is one of the worlds at the center. That's just to represent that one may have false beliefs. Okay, so it's not a centered system of spheres. Okay, so if you're familiar with the AGM theory of belief revision, which is just an axiomatic theory, okay, it has a bunch of postulates. Those postulates represent super highly idealized doxastic agents of believers. Okay, the first postulate says that this is just the notation that they use. It's classical notation. This is belief set. So this K, it's a syntactic presentation. So that's not an operator with the semantics. It's just a set of formulas closed down the logical consequence. It represents the agent's beliefs. So this whole thing reads belief set K after revision by phi. Okay. So that's closed under the full strength of classical logical consequence. So the agents believe all the logical consequences of the thing that they believe, even after revision. The fifth postulate trivializes belief sets revised in the light of inconsistent information. But it says, if phi is a logical inconsistency, when you revise by that, you get the trivial belief set, so you believe everything. So these are agents such that whenever they revise by something which is an impossibility, they believe everything. So they're very fragile when exposed to inconsistent stuff or impossible stuff. And also, guess what? It's not Hyperintentional, of course, because another postulate, the sixth one, says if phi and psi are logically equivalent, then when you revise by either, you get the same result. So these are agents who cannot discriminate between equivalent, logically or necessarily equivalent contents. Okay. I want these things to go, of course. Against the first postulate, our belief sets need not be closed under classical logical consequence. Against the fifth postulate, we do not trivially believe everything just because we occasionally hold inconsistent beliefs. I may have inconsistent beliefs, not because I believe whatever. And against the sixth postulate, how we revise beliefs is subject to framing effects, for instance. Okay? Agents may revise beliefs in different ways when given equivalent information. When they are told that they have 60% chances of succeeding in a task, they may believe something. They may believe something different when they're told they have 40% chances of failing. Even though they have to, put the same possible worlds, right? Okay. Actually, in the book, I have a more sophisticated setting to represent framing effects. Now I'm going to talk about that because that's already enough. So the first condition gives us the so-called AGM. So there are some postulates of AGM that I will cover in my setting. Okay? The first one is success, which is fine, at least for static belief revision. So conditional on phi, you believe that phi. But against the fifth postulate, we do not come to believe arbitrary things due to inconsistent information. So a kind of explosion fails here. So even though the setting is very classical, contradiction is not the case that you believe arbitrary things. So you can revise in the light of explicitly inconsistent information. You don't end up having believing anything, any psi whatsoever. The idea is that, well, inconsistent information still has a topic. It's about something. Phi not phi. It's not contentless, so to speak, in this setting. The topic is whatever phi is about. Okay? And this may not include the topic of psi. Snow is white and not white. It's inconsistent information, but it's inconsistent information about the snow. And the color of snow tells you nothing about grasses being purple. K6 fails. So this is just an abbreviation for phi and psi are strictly equivalent. Okay? Phi strictly implies psi and vice versa. And this captures a kind of frame. So sometimes conditional on phi, you believe chi, and phi and psi are co-intentional, but it doesn't follow that conditional on psi, you believe chi. So for instance, after being informed that the probability of making it to the shortlist is 1 and 3, one believes that one should apply for the job. But after being informed that one's probability of failing the shortlist is 2 and 3, one does not believe that it's worth applying for the job. Okay? Even though those two bits of information are co-intentional. There's no way that the chances of making it are 1/3 without the chances of failing be 2/3 and vice versa, but one has been caught into a framing effect. C3, equivalence implausibility. Remember, that was the complicated condition that says if all the 5 selected words makes group psi and vice versa, then the 2 set selection functions pick up the same set of words. That allows a limited recovery of the idea encoded in the so-called extensionality postulate of AGM. So this is valid. So this says if conditional on phi equals psi and vice versa, conditional on psi equals chi, then you can replace phi and psi here, whatever chi is. So you have a limited substitutivity. Unrestricted substitutivity of logical equivalence of co-intension formulas doesn't hold, but this restricted substitutivity holds. Okay, and that kind of makes the belief operator a bit more regimented. Equivalence implausibility are formulas phi and psi such that when we divide by either, we can't believe the other. Substitutivity now says that such equivalence can be replaced arbitrarily as equals for belief provision, whatever chi is. When we divide by either, we come to have the same beliefs. Okay. So a lot of people are working on this stuff. There are some complete axiomatizzations of the semantics proposed here. You've got Bayala, Giordani, Ibuke, and other people. Ibuke is also caught in a couple of chapters in the book. Heinrich Bansen is working on how to combine the meaning of the operator I did not tell you about, the one in which it represents suppositional thinking or imaginative thinking. Heinrich is working on how to combine that with a certain approach to the logical imagination that he has been developing. And imagination is understood by him exactly as suppositional thinking. He uses state logic, seeing to it that logic. That's a sophisticated modal logic. Okay. I think this is cool stuff because, I mean, there's a huge amount of work on in epistemic logic on the logic of knowledge. There's a huge amount of work on the logic of belief and conditional belief, plain belief, belief revision. There's very little work on imagination, even though imagination, that's also an intentional state of the mind. Okay. Yeah, so this is good stuff. Final point I want to make, and I'll mention that as something to be developed next week. All the TSIMs embed the draconian topicality constraint. Remember, that was the second bit in the 2 conditions. The topic of psi, what psi is about, must be fully included in the topic of phi, what phi is about. Not just overload, full inclusion. Okay, that's a pretty tough requirement, and one may think that it's too tough. Okay. If it's too tough, you can relax that constraint into a kind of a weaker claim. You don't claim that the topic of psi is just included in that of phi. You claim that there's a topological connection between phi and psi. At the end of chapter 5 of the book, I come up with something along these lines, exploiting ideas that Ibuke had, and also my friend and colleague Aaron Kotmar, the king of mereology, because Aaron got into that, and Aaron is a lot into mereotopology, and so he said, well, why don't you replace that draconian plain mereological inclusion requirement with a more sophisticated constraint of mereotopological inclusion? I'm not going to talk about this now because I've already thrown tons of stuff at you, but I'll give you an idea of how this works when we, next week, when we talk about how to combine conditionals, probabilities, and topicality together. That's going to be a topic for the next lecture. Yeah, I'm going to stop here and thank you. Thanks. Little break and questions?
That's right.
Of course, X can disappear. Yes, we can talk about it. So we talk with us not yet.
Oh yeah, that's me. I just in case I need it for that. I wanted to have the Lewis system of CS. Maybe the system of CS would be needed.
Okay, so well, thanks for your talk, Franz. It was well, I'm sure there are plenty of questions.
Good.
And we have time. We have time for whatever questions we may have now. So for Ricardo, please.
Yeah, so like in previous sessions, you told us that like a good chunk of the argument in favor of thick propositions was gonna depend on showing how this formalism can do wonders, like good stuff.
I wouldn't say good chunk, just
Okay.
part of the whole
Okay,
story.
it looks, I mean, I believe you.
Yeah.
However, and correct me
Yeah.
if I'm wrong, I didn't see anything in this formal framework that requires big propositions. You know, there's nothing that tells me that the topic has to be one of the members of the proposition. Like, nothing tells me that propositions have to be pairs of intentions and topics, unless I miss something.
Yeah, actually it does, because remember that the semantics starts by assigning to each, besides assigning to sets to formulas, it also starts by assigning topics to all the formulas of the language. So there's a topic function which assigns a topic, so subject matter to each atomic formula. And then each formula of the language recursively gets assigned the topic of subject matters.
Right. So
they all are assigned to sets, and they all are assigned the topic. So they are all assigned to component contents.
but suppose I tell you propositions are not big, but still there is that function that pairs sentences with topics.
Yeah. I would say that that's a merely terminological point. You could have said that already yesterday or last week. So when I gave you the two component setting, in which I say that position is made of the truth set and topic. This notation, you could have said, well, but I only want to call this one proposition. So what I call a thin proposition, you call a proposition, and what I call a thick proposition, you call a pair of a proposition and something else. But then the disagreement is really terminological. I mean, it's not merely terminological, because you may insist that the only things that deserve to be called propositions are sets of words. And so you may take exception with my insistence that the whole pair deserves to be called a proposition. But yeah.
All right, cool. Fair enough. Thanks.
Okay, Santiago.
Yeah, thank you very much. I have a question, as you can imagine, about knowledge closure.
Yay!
So suppose that I am an old-fashioned epistemologist, and I want to see what is the job that your two-component view is doing to reject knowledge closure.
Yeah.
And maybe I misunderstood, so maybe that's a clarificatory question.
Yeah.
An objection, it depends on how you take it.
So I take it that this is the focus, right?
Yeah. So I have a question, is about what is doing the job? Is your two component semantics or the assumptions that you are building into your two component semantics? Because it seems to me that you have two substantial assumptions at least, and those assumptions are in mainstream epistemology and not part of your framework.
Okay.
One of them is we're going to explain knowledge via a non-factive notion of information.
Okay.
And the second one is that information is understood as a non-factive notion. So when you have these two assumptions, you have everything you need to get your result.
Okay.
So then I just don't see what are you adding beyond these two assumptions that you relied on that give us an additional reason to just reject an unrestricted knowledge closure principle?
Good. I think the philosophical story is the other way around. So you start by liking the idea that knowledge is not closed under full logical consequence. And you like it for whatever reason that is maybe connected to the Kripke-Harman dogmatism paradox, which we do solve, or so we claim in the paper and in the book, because you think that that's the best way to address skeptical worries. Okay. So you reject the idea that knowledge is fully closed under logical consequence. And then it's up to you to say under which restricted closure principles your notion of knowledge is closed. And that's a question to which anybody who rejects full closure has to give an answer.
I see.
And better be a good answer, because there's the Kripke ghost hunting you, because not just Kripke, also Williamson or Hawthorne. The dialectic there is such that they tend to press the point that extant accounts of knowledge, in which knowledge is not closed, also make knowledge fail certain closure properties, which should not fail, which have nothing to do with addressing skeptical paradoxes and so on. Okay, so you start by having this bunch of philosophical desiderata, and I come up with a framework that I claim fits the bill. Okay, that's kind of the way I would see the story. So it's totally motivated by taking on board views which are already out there in mainstream epistemology, and try to come up with something which is formally precise.
Can I yeah, so okay, let's take your starting point. Then that leads me to my second question. So your formulation, I don't understand why you formulate closure that way, and you do not relativize that to known logical consequences.
Right, good. That's a great question.
Yeah, because I mean, there is a very easy way of rejecting this.
Yeah.
Is that you say, well, there is the problem of logical omniscience.
Yeah.
No one wants to make knowledge depend on logical omniscience, so that's not a closure principle that is worth fighting for. So we want a more restricted knowledge closure principle, in which if you know that P and you know that P entails Q,
Right,
then
great.
you know Q.
This is about the semantics, and that's what's worrying you. Because sometimes when people debate on knowledge closure, they have this one in mind. Because you will say, yeah, you may not even be aware that if you're hands, then you know handless brain in the vat. But the problem is when you find, you know that you have hands, you know that you have hands. If you have hands, then you are not a brain in the vat. And then you know that you're not a brain in the vat. Okay?
Yeah.
So, yeah. And indeed, this is valid in the semantics. So that's well spotted. That's a smart epistemologist. Yeah. So that's where the bit phi here does its job. This is valid in the semantics, but that only tells you that based on certain information phi, you're positioned to know that psi, and based on the very same information, you're positioned to know that if psi then strictly chi. Then based on the same information, you're positioned to know that chi. Okay. So it needs to be the same index throughout, otherwise it's not valid, the infinite doesn't go through. Now, what I claim is that the basis on which you know the two things are very different from each other indeed, and you cannot even pull them together, because you know that you have hands on the basis of ordinary empirical information. That's not the basis on which you know that if you have hands, you're not a brain in the vat. That's it may be conceptual knowledge or some kind of knowledge.
Yeah.
There's another principle which is invalid in the logic. I think it's called unwise adjunction in the book. So that's a principle that says, if based on phi 1, you can know psi, and based on phi 2, you can go chi. It does not follow that if you put the bases together, so on the basis of phi 1 and phi 2, then you can know psi and chi together. So that's invalid. Given this, you can know this. Given this, you can know this. You cannot pull the two bases of your knowledge together and say on that conjoined basis, I know the conjunction. Okay, so given certain empirical information, you're positioned to know that you have ends. And given certain very different kind of information, conceptual or whatever, you're positioned to know that if you have ends, then you're not to bring in that. It doesn't follow that you can pull together information and on that basis know that you have ends, and if you have ends, you're not to bring in that. That's enough.
But isn't that just like what people sometimes call a transmission principle and not?
I think that, yeah, that's close to what people call a transmission principle.
Yeah.
I think so, yeah.
Okay.
So the idea here, the underlying philosophical idea is that knowability is always knowability relative to some base, and you cannot always lump the bases together. That's an idea that you find in some mainstream epistemology and so on.
Okay.
Yeah.
Okay, thank you, Abraham.
Yeah, I think you already answered the question that I was going to ask. I was thinking in the next case scenario, right? We can have knowledge that phi, given the certain information,
yeah,
and we can have knowledge that psi, given certain information, and this is about the same topic. Let us assume for a moment. And then the conclusion should be the conjunct, right?
Mm-hmm.
But the information relative to that conclusion has to be with our logical knowledge, not the empirical knowledge that we have about phi and psi.
Mm-hmm.
That phi and psi.
Mm-hmm. So what's the question?
If that difference typicality is like a problem, because they're not about the same topic, and we cannot like conjoint both unless we have in our information basis logical knowledge and our empirical knowledge.
Yeah, there doesn't seem to be a problem for me. Yeah, well, all that you say, I agree, except that I fail to see why that would be a problem.
No.
That may happen when you want to model an agent which has some kind of limits to their logical competence, for instance. That would be a way.
Yeah. Thanks.
Okay, Grace, please.
I was thinking in the connection of all of this with connective logic.
Yeah, oh, okay.
Yes, you know that in that case, implications of the form phi implies not phi are defective, logically defective.
Yep.
So the negation of that gets validated.
Yeah.
In several ways. And I was wondering what happens in this case with the conditional belief, conditional on phi. Can you believe? Phi? The case of that, is that satisfiable in those minutes?
Conditional on phi, let me get that. I think you are in the ballpark of a problem. Framing, what was the inconsistency? Oh, there you go. Conditional on phi and not phi and not psi, you believe psi. And the other way around, conditional on phi and not phi and psi, you believe not psi. These are variant semantics.
Well,
so if you were thinking about something like that, that is bad. I agree.
Yeah.
So when I said the explosion in this sense phase, so it's not the case that based on inconsistent information, phi not phi, you believe anything. Okay. What I didn't say is that this one is valid though. So it's sometimes called small explosion principles. It's terminology that you find. This is valid, unfortunately for me. conditional on phi and not phi and psi, you believe not psi. And the other way around. This is valid and this is bad. It's kind of a small explosion. And not in this setting, but in a similar setting, Harry Deutsch at the point, he calls this the mistake of making too much of a small error or something like that. It still sounds bad that if I believe that snow is white and not, so conditional on snow is white and not white, and grass is green, I believe that grass is not green. That is bad. Who do I blame? Well, that the setting is so classical.
Yeah.
So even if conditional, so you believe anything which is both entailed and on topic, that is the problem. You don't believe anything which is entailed classically, but you believe anything which is entailed and topic sense. Because the point is that this bit is what allows this guy to step into, it's not filtered out by the topicality filter. So in the book I say, yeah, that's where non-classical worlds and non-classical logics get their revenge. That's where this setting cannot do all the job that you would get in a proper and consistent account of belief division, for instance. Okay. You don't have that kind of problem in a decent, para-consistent based account of belief division. But all of this is due to the fact that this is invalidated not by non-classical worlds and so on, because everything is classical. This is invalidated only by the subject matter filter. And the subject matter filter cannot kick out that one. Okay. Yeah. So that's where I just say, yeah, that's because I was so conservative. And the non-classical logician in me is kind of happy that there's a problem there. Yeah.
Thank you. Stefan?
Well, I want to ask a question which is probably completely confused, but surely if that's the case, I'll benefit from your answer as well. So I was thinking about the tricks you made to take care of no-six problem pointed out by Kripke, but I was just thinking, what if we think of no-six counterfactuals, tracking the truth, or redefining in terms of tracking topicality and truth, and what do we get from that? It wouldn't be a way to say something like his kind of definition of knowledge.
I know that phi, when I wouldn't go wrong in the closest worlds. Yeah. I wouldn't falsely believe in the closest worlds.
Yeah.
That fails conjunction elimination, and Kripke says then the account is doomed. And now you're asking me, what if I add subject matter sensitivity or topic sensitivity to the Nozick account?
Yes.
It's not going to help him because when you add the filter, it only makes the logic weaker. So if it failed the conjunction elimination in the Nozick account, it's going to keep failing that in my account, unless you have some more complicated way of adding subject matter sensitivity. So any obvious way of adding topics to the Nozick counterfactual tracking account is just going to make the logic of that operator weaker. And so you will keep being in a situation, it will still be allowed that you know a conjunction without knowing the conjunct separately, and then Kripke will be after you. Yeah. Yeah, so I don't think that that's going to help Nozick.
Thanks.
Are there any more questions?
Yeah, a very general question about the anti-skeptical implications. So
about say it again.
The non-skeptical implications.
Oh yeah.
So some people, again, the old-fashioned epistemologist talking. Some people would say, look, maybe you are dealing with the easy skeptical problem. There is a more difficult one, which is related to evidence, under determination. Do you have any view about that? I guess you can just bite the bullet, say, well, I don't have anything to say about that, or you could extend your framework. So here is the kind of argument I have in mind, under determination. So if you are, so there are many formulations, but you could say something along the lines of, if you have evidence for P, and you know that P is incompatible with Q, then your evidence
That's against you.
Yeah. So you can formulate an argument of that kind. And because your evidence can favor P over an incompatible alternative without being sufficient for knowledge, those paradoxes are not equivalent. So would you have something to say for this kind of
that would depend on how one embeds evidence into the account, because I never talked about evidence when I gave you the KRR setting. And I told you, well, that was a strategical choice because either we didn't want to commit to the view that evidence is not factive rather than factive and so on. So we went for information and we are neutral on that. I don't think the account is going to work if you just replace information with evidence. So if you relabel the thing as knowability given relative to evidence, but you keep the logic as it is, I don't think it's going to help with those underdetermination cases. But those are cases of underdetermination of evidence.
Yeah, what I had in mind is that maybe you would have a way, that would be a nice thing to do, of formalizing relevant alternatives. So basically what many people complain about is what counts as relevant, as a relevant alternative. We don't have a very precise formulation of that. And that's one of the reasons why that kind of view is very intuitive, but many people don't know what to do with that. So I was supposing that you would go that way and you would say, well, I give you a way.
Yeah. I have a way to capture relevance, of course, via my subject matter filter. Yeah, good. I don't have a lot to say, but Peter Hook would have a lot to say because I mean, he was the in-house epistemologist when we started with this stuff. And he worked a lot on, he has an account of subject matter, and he has worked a lot on relevant alternative theories. And I think he has at least a couple of papers in which he shows how you can use subject matter sensitive semantics to give a precise treatment of relevant alternative views. So I would just point you at stuff that he has written. Yeah. So I don't know, but I think you can find cool stuff on exactly this topic in his. He has papers on skepticism, closure, subject matter, and relevant alternative theories. So so look at what Peter says.
Okay, thank you. Anyone else? Rogelio?
I have a doubt. How would that theory work when both are synonymous, like a vixen is a female fox? Peter knows that a vixen is a female fox. How would topics work in that case?
So what are the relevant sentences here? So a vixen is a female fox is the sentence. Yes. Okay. And then the next one is Peter knows that what?
A vixen is a female fox.
So he knows that. Okay. And then
the example that gave Williamson, female fox is a vixen.
Yeah. Peter knows that, right? Peter knows that in your setting. Okay.
Peter knows that.
Maybe you want to have like Peter knows that the vixen is a vixen and the vixen is a female fox, but Peter doesn't know that a vixen is a female fox. Okay. That depends. I myself am not inclined to deal with these kind of cases using subject matters or topics. Because that's a situation in which Peter is just semantically not competent. He doesn't know, I guess, what vixen means, right? Yeah. I wouldn't deal with these cases using subject matters and so on. Subject matters allow you to make distinctions. That clearly is a hyperintentional context, okay? Because Peter knows that a fox is a fox. Peter doesn't know that Peter knows that a vixen is a vixen, or whatever, or that a female fox is a female fox. He doesn't know that a vixen is a female fox, okay? But the two claims are intentionally equivalent. right? That were the same possible worlds. I don't think that's the kind of thing that is dealt with by invoking subject matters or topics. Maybe they need to be dealt with by using guises or modes of presentation and so on. But I don't think topics are a suitable tool to deal with these kind of hyperintentional cases. Other people don't think that. So Peter Hoek, again, I mentioned him again, he has an account that can deal with these cases using subject matters. But I suspect that that's not where subject matters should go. Because I think that when it's about substitutivity of co-referential terms or even of synonyms, the intuitions on what we are talking about are a bit shaky. An example that I give you the other week, like Lois Lane loves Superman, is not the case that Lois Lane loves Clark Kent. Okay. It's not clear that the subject matter is different to me. Maybe in both cases, we're talking about that guy, or whatever unique topic is associated with that guy, Kal-El. And I'm one of those people who work on topics, but don't think that it's the job of topics to take care of these cases. I think one still needs to invoke what people often invoke, guises or modes of presentations and so on, things which according to lots of people don't belong in semantics. Okay. Yeah. So yeah, but not everybody has this view. So Peter has a richer account of subject matters in which he can account for these cases, but that's because he's kind of building Freudian senses in his account of propositional contents. It's a very powerful account because he has senses that were kind of like modes of presentation, but they are in the content of the proposition. So the superhero with the costume, blah, 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 the shy journalist wearing glasses, blah, 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 and so on. And for Peter, these are senses that show up in the relevant subject matter sensitive propositional contents. But even he is worried that his account is labeling a subject matter thing that, yeah, this should not be there. Okay.
Can we see what else is in that slide? Because you went very fast.
Oh yeah, I skipped this one. Actually, that's general, because that was in the slides on mental simulation. I think that all of the TSIMs underdetermine that content in the following sense, that we can imagine things vaguely or believe things vaguely or know things vaguely without this entailing that we imagine or know or believe vague things. So the vagueness is not in the things out there. That's because distribution in this sense space for all the things. So conditional on phi, you believe psi or chi, for instance. It doesn't follow that conditional on phi, you believe psi, or conditional on phi, you believe chi.
You mentioned.
Yeah, but that applies whatever meaning you have for the things. So that also applies to the knowability relative to information operator. It also applies to the conditionality operator. It's just that I discussed that in the context of the supposition or imagination operator. But it's the same thing. It always fits for all of that. So for instance, because this was a slide in the context of the supposition or imagination operator. So you're reading a novel, the novel gives you a certain input, you're reading a Conan Doyle story, and the story prompts you to imagine certain context. So you imagine Sherlock Holmes as a normally endowed human being because Doyle tells you that much, just a guy. So given the input from the story, you imagine that Holmes is either left-handed or right-handed, but it doesn't follow that you imagine him as left-handed or you imagine him as right-handed. That's just like undetermined in the story. So the semantic gives you that. Okay, that's just the underdetermination at issue here.
Is that supposed to happen in all the cases, in a sense, defective information, not only vague, but also inconsistent? Because in the case of inconsistencies, you imagine inconsistent things, right? Ideally,
yeah.
If you're thinking of an experiment, so
So if the input here is maximally detailed, then that's not going to work. So the reason why this fails is that you look at the bunch of worlds selected by the function that comes with phi. Okay. So some of them, this may come out true because some of them make true psi and some of them make true chi. Okay. But it doesn't happen that all of them make true psi, and it doesn't happen that all of them make true chi. That's how you get the relevant time with determinacy. So the idea is that that input phi lets you look at the plurality of words, and some of them only psi is true, and some others only chi is true. So the disjunction holds throughout this set of words that you're looking at, but it's not the case that either disjunct looks throughout that set of words. But if you have super specific input that allows you to pick out one single word, okay, then that's gonna hold. So it's the fact that you access a plurality of words via the initial input phi that allows this to fail. But if the phi is so specific that it allows you to pin down a unique word, then this is gonna hold. Yeah, but I mean, in ordinary life, that's never gonna happen. Like the information is always gonna allow you to look at the plurality of possible words. Yeah, so it's a very special case, the case in which your information is so specific that you single out a single word, given that input. Yeah. So this is not an invalidity given by the topic filter, it's just given by the fact that you access a plurality of words. Yeah.
So basically, there are prime lattice.
Yeah, that's right. Yeah.
There are any more questions? But I mean, we only have a few minutes left anyway. So if there are no more questions, and
Thanks a lot.
I think we.
Thank you.